Edexcel Core Pure, Calculus 6, volumes of revolution and the mean of a function. Rotation about the x-axis for parametric curves. We've seen how we can do volumes of revolutions in previous videos. Here the orange curve that you can see on this graph has been rotated at 360 degrees about the x-axis to create the grey solid. So we spin it all the way around the x-axis to create this solid three-dimensional shape. And just to remind you that the volume of revolution was found by finding the sum of a series of thin cylinders, each of width delta x, and finding the sum of that total as delta x tends to 0. So now we're going to look at a volume of revolution where the curve has been given in a parametric form. Now parametric equations are in the A-level specification, but if you haven't covered them yet, then you may choose to come back and watch these videos at a later stage. So as the parameter t varies, then it controls the values of x and y. So in this particular example, x is t squared and y is 2 minus t, and we can see the curve there. It is often easier to stick with these parametric equations rather than rely on eliminating t to go to a Cartesian form. Usually the algebra is easier if we work with parametric equations. So we're now going to find the volume of revolution using the parametric form. So we know it's the curve x equals t squared y equals 2 minus t. It's been spun about the x-axis, and we're going from x is 0 to x equals 4, and the volume of revolution formula we can see at the top of the screen. So we're looking for the volume of revolution and we're going to use parameters. So we know that the volume is the integral of pi y squared dx from x equals 0 to x equals 4, just quoting the formula that we are given. We're going to substitute for y, but we also need to substitute for dx. One way of doing that is to have a quick look at x equals t squared. Therefore dx by dt is 2t and dx is 2t dt. And don't forget to consider the limits as well. When x equals 0, what will the parameter be? When x equals 4, what will the parameter be? So if x is t squared, when x is nothing, t will be nothing, and when x is 4, t will be 2. So this integral becomes the integral from t equals 0 to t equals 2 of pi. Y squared we know is 2 minus t all squared, and dx is 2t dt. So expanding these brackets and multiplying by 2t as well, this becomes the polynomial 8t minus 8t squared plus 2t cubed dt. So all we've got to do now is integrate this polynomial carefully and sub in the limits from 0 to 2. So integrating with respect to t, we're going to get 4t minus 8/3 of t cubed plus a half of t to the 4. And now subbing in the top limit, we get 8 minus, subbing t's 2, we're going to get 64/3, and then subbing in the t's 2 again, we're going to get 8 minus pi, subbing in the bottom limit, is clearly going to be 0. Always subbing the bottom limit even if it's a trivial case. Tidying up this bracket, we get the volume of revolution is exactly 8 pi by 3. We could always check this definite integration that we've done here using the facility on your calculator if you wanted to double check it. So the key things here are to substitute for y. You may think of dx as being dx by dt times dt. That's another way of setting it out. But either way, the full substitution will produce the integral of this polynomial, which is 8 pi by 3. In the next video, we're going to be looking at rotation about the y-axis for parametric curves.